The Secrets of Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit givestarquest.com.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
All right, Caroline, here we go. Tell us about the wonderful science of frozen mice brains.
So yes, today we're going to be talking about thawing out and bringing back to life mouse brains. Well, at least
Happy
part
Easter,
of the brain. Happy Easter. But the thing is, they can actually make them function again after being frozen. Let's get into it. So cryobiology is the branch of biology that studies the effect of low temperatures on living organisms, on biological systems and their components, such as proteins, cells, tissues, and organs. And usually cryobiology primarily focuses on how life survives or sometimes fails to survive at temperatures near or below the freezing point of water, which is 0 degrees or 32 degrees Fahrenheit. So the greatest obstacle in cryobiology when it comes to preserving life isn't actually the cold. It's the phase transition of water. So our cells are essentially like salty envelopes of water surrounded by a lipid bilayer, like fatty cells, fatty molecules. And the water is one of the few substances of Earth that actually expands when it freezes. Now, as the temperature drops toward 0 degrees, water molecules begin to align in a rigid, hexagonal, crystalline lattice. And what happens then is the crystals behave a bit like microscopic blades. So they don't just freeze the cell, they physically puncture the phospholipid bilayer, which is, as I mentioned, the outer cell layer of our cells. So for the brain now, so it's defined as its hypercomplex connectivity made up of neurons. So the crystallization of the water is catastrophic. So it doesn't just kill the cells, it actually untethers the synaptic bridges that house our memories and identity. So there is a team that's had a look into this. So it's been published in a study published in the Proceedings of National Academy of Sciences earlier this year. They've kind of found a way to bypass this destruction. So a team at Friedrich Alexander University in Germany has moved beyond freezing into the realm of vitrification. What is vitrification? It's the process of turning a liquid into a glass-like solid without the formation of any ice crystals. So they found that by cooling the brain tissue at extreme velocities, often exceeding hundreds of degrees per minute, in the presence of cryoprotective agents, and these are like a biological antifreeze. They didn't freeze the brain, they turned it into a kind of biological glass. So usually to achieve this vitrification and prevent lethal ice crystals, you need high concentrations of cryoprotectants like chemicals such as DMSO or ethylene glycol. Now, as I mentioned, these are essentially a biological antifreeze. However, while these prevent ice at low temperatures, they are toxic to cells at warmer temperatures. They can actually interfere with protein folding and trigger cell suicide pathways, so the cells actually die. Now, the team was able to use an alternative method called the washout protocol, meaning as the brain thaws, the chemicals are removed. However, if you rinse them out too quickly with a standard saline solution, you trigger something called an osmotic shock, which means that the concentration of the chemicals inside the cells is so high that water from the outside rushes in to balance it out, which actually causes the cells to swell and burst.
Wow.
So that does no good either. So to counter this, the researchers developed a hyperoncotic solution, which means the solution uses a high osmotic pressure to take up the toxic cryoprotectants out of the cell gradually. In this way, they balance the pressure and the concentration of the cell, allowing neurons to return to their natural state without the structural collapse that usually follows this kind of cryopreservation. Now, the researchers focused their efforts on one of the most vital regions of the mammalian brain called the hippocampus, and specifically in the CA1 region. And this region is called the librarian of the mind or the brain, responsible for encoding new memories and spatial navigation. So in previous decades, we could preserve the look of the cells. They looked fine under a microscope, but they were functionally silent. They didn't work anymore. They look good, but they don't work. So the study that was performed aimed to change this from an appearance of cells looking good to actually an action, so the cells working. So the team looked for electrophysiological activity, or basically brain function. So what they did was they kept the mouse hippocampus tissue at negative 150 degrees Celsius for 7 days. Then they initiated a control rewarming. Then once the tissue returned to physiological temperatures, so like normal functioning temperatures of the body, they applied an electrical stimulus to the neural pathways. Now, what they witnessed was something called, well, they termed it the holy grail of neuropreservation, which was called long-term potentiation. So what is that? Long-term potentiation is the cellular mechanism of learning. So it occurs when a high-frequency burst of activity strengthens the connection between two neurons, which makes them more likely to fire together in the future. So if LTP, for short, survives in a deep freeze, it means the molecular machinery that acts as the gates for this communication is still functional. So the brain, the software of the brain isn't just stored, but it's kind of ready to run, which is pretty cool. So researchers found that the mouse brain cells didn't just survive the freezing process doing this, they actually woke up and they resumed complex biological functions. Pretty amazing. So I'm saying this is a major breakthrough because historically, thawing the brain tissue resulted in like a gloop due to ice crystals shredding the cells. But, you know, by using this vitrification process, they actually were able to observe the following behaviors in the cells, in the neurons. So the most significant finding was that the neurons in the mouse brain began actually firing electrical signals again. They weren't vegetative. They were working. They were actively communicating. And they also found microscopically that the membranes, both the neuronal and synaptic membranes, were preserved, which allows for normal signaling. The mitochondria of the cell, so these are like the power plants of the cell, these actually restarted and began producing energy again with no sign of damage. Yeah.
Wow.
So while the cells weren't perfect, because, you know, there's always a bit of a deviation, the behavior was actually described as near normal in the study. So that's pretty amazing. And
that's how my brain activity is described, by the way.
Oh,
yeah.
Near normal. Yeah. Especially these days.
Semi-normal. Yeah.
As the year grinds on. Yes. But so why are scientists freezing mouse brains and trying to get them to work again? Well, they're hoping that maybe this kind of research can lead to preserving organs. So like, you know, there's a lot of need for organs when, you know, you may need to get a new kidney or a new liver or a new heart or whatever for some other reason. They may be able to actually start freezing these organs, because usually once a person dies and you take their organs, there's only a limited time
Yep.
that the organs can be preserved. It's a very quick thing. It's got to happen straight away. And sometimes the organs can be damaged if they're not delivered on time. So they're thinking that this can be used to preserve organs in the future and, be a really valuable thing in medicine. So, yeah, it's just something I thought was pretty interesting, and I thought I'd share it with everybody.
I think that's really fascinating. So whenever you talk about a science topic, I always have a lot of questions. Just like, teach me, master. So firstly, like a curious question, like the mouse brains, are we talking about like with still inside the mouse's head, or are we talking about, did they extract the brain and then try this out?
Unfortunately, in this kind of research, poor little mices don't make it.
Yeah. Well, I know that they use them for research, so yeah. They do take out the brain tissue, and they're looking at the brain tissue. Yeah, because it would be interesting to see. I mean, poor mice. I do say poor mice, but it would be.
Me too. I used to have them as pets, so I actually really love them. Yeah,
I know. Yeah, I know that. Yeah, you love, and you love all animals. Yeah,
I do.
You're like,
I do.
You're little of size. They can talk, But I wonder if this could one day be applied to a living thing, like a mouse, a living mouse. Putting it into this, it seems like almost like a deep sleep kind of thing, really, in a way, and then thawing it out as a way of, and also as an application to human beings one day. Like, for example, if it's got, a treatment, a time critical treatment that you need, but it can't be done there and then, and then putting someone in that sort of state, I don't know, like what, because it seems like the achievement of this was that no damage was done to the cells and they're able to be woken up again. So like, let's just say that you need immediate treatment, but for whatever reason, it's a week away before you can access it. But again, this would be a lot of testing, because we don't know what it would do, say, on the psychology of a person. I guess there's that to look at as well.
Totally. But, there's a lot of ethical implications when it comes to doing it a full body human, for sure.
Yeah.
I mean, there's all this, science fiction of putting people to sleep in space and then waking them up when they're
freezing them, and things like that.
Space travel and stuff like that. So, like, you can really, you can expand it into.
Yeah, like when a colony goes silent because it's been overrun by aliens and they have to freeze the people for the months-long journey for them to get there and see what. Yeah, exactly that. Yeah,
that's it.
Yeah. Not real, folks. Right now.
No, not yet. Not yet. We're just at the cellular level right now. But it's pretty interesting. I think that, it definitely could have medical implications, medical benefits later on, if it helps to save lives.
Yeah. But even like you said, storing organs, for transplant is, a major one, because that is a time critical for sure, right? Like once you have the organ, you can't just put it on ice or whatever, really. You've got to get it. Yeah. The other question I had was, is this the reason why, sorry, it's a bit graphic, but like when someone like severs, like say a finger or, something like that, or something else, is this why they say you don't freeze it? Because it will, like the cells will be damaged by that, by the water becoming like, like you're saying, like razors or whatever it was.
Absolutely. Yeah. No, you don't want to freeze it, because it's true. The cells actually do get destroyed. And then like we were talking about the osmotic pressure as well. So, the cells can burst as well once they're thawed if, the concentrations are wrong inside the tissue and all of that. So do not freeze them. Just wrap it up, keep it, take it to the doctor straight away if you've cut your finger off, and hopefully they're going to be able to save it for you. Yeah, absolutely. But hopefully no one gets their fingers cut off.
Yeah, that's right.
Anytime soon.
First aid advice, but we never hope would happen to anyone, of course.
That's it.
Yeah. That's really fascinating. I wonder, hopefully we'll, as we follow this research, we'll see what happens next in terms of what they can do. I mean, it's probably, I mean, yes, it's the holy grail of, putting cells to sleep and waking them up again, but it's probably, as always, it's probably years away before it can be applied to anything in a very useful manner. In that way, I guess it's probably steps of research that need to happen next.
Absolutely. And And if you do get to the organ level, like I mentioned, there's ethical implications. You can't just be putting thought out organs into people without knowing that the organ is functioning properly and all of that, because it's a serious surgery to have that done. You only want to have it done once. So there's a lot of experimentation to be done. But, everything starts with little steps and, that's how it always happens. And eventually we get to these medical breakthroughs that are amazing for later on.
Yeah. Well, let's see what happens in the future. If there are any updates on this, we'll be sure to do another science segment to talk about any future updates on it.
Absolutely.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest. Here's another show on the StarQuest network you're sure to enjoy, The Secrets of Movies. Find it wherever fine podcasts are found or at sqpn.com/secrets.